in this workshop, I hope to go over just how to do kind of basic Rust and just get you kind of on-ramped enough to, kind of understand the easy parts of Rust, I guess, enough to like get you comfortable if you're working on a hackathon project for, we've got like, Arbitrum has $18,000 towards Stylus grants for this hackathon. So and usually these tracks don't get a whole lot of applications compared to a lot of other ones. So usually if you submit something, you got a pretty decent chance of winning a prize. So this can be a highly useful skill, and it's something that I hope, like, if you know another language and you're not really familiar with Rust, I hope you can like at least understand a couple of the basic parts of Rust to, if you know something else like Java, JavaScript, you should be able to get on-ramped enough to build something for this hackathon and put something together. And it shouldn't be too intimidating for you. So we'll just, we'll kind of stick with Rust, the easy parts for this demo. But yeah, that's my name there. I would go by Crisco. Crisco512 on Twitter and also Telegram. Feel free to DM me. Yes. Oh, I'm sorry. Share something? Yes, that, right? Yeah. I'm just, I'm about to change the slides. All right, thanks. So what is Stylus, by the way? If for those not familiar, it's a parallel VM that runs on Arbitrum chains. And essentially it runs as a sister VM to the EVM on Arbitrum chains. And that means that you can, when a contract is compiled in WASM and deployed on chain, there's a small little header that gets deployed with the bytecode, and Arbitrum will either run it in a WASM context in the WASM VM or the EVM, depending on what that bytecode gets interpreted as. And it remains fully composable with the EVM, so it's not like a separate execution environment altogether. It still shares a storage state with the EVM, so you're able to store data in the same co-locations as other Solidity data. So it's just fully composable with Solidity, and as you can see, other languages are supported. We're going to go over Rust here, but you could also use Zig or C or AssemblyScript or any other like systems type language that compiles to WebAssembly. It could be very powerful for that. But for we just built the Rust SDK for now as a central focus for us, but we are excited to support other languages in the future. But for now, we just got our Rust SDK to use. But the main benefits of Stylus is that you get access to 70 times more compute per unit of gas versus the EVM, and 1,000 times more memory. And that's because the WebAssembly VM runs closer to like bare metal assembly instructions. And so there's less virtualization and things like that going on in the Arbitrum nodes. And we pass those gas savings on to developers and to users of the blockchain. So whenever you're doing something computationally heavy, Stylus is a prime, that's where it shines. Storage costs tend to remain the same as Solidity costs. So if it's just a storage heavy, or just it only has like a few additions, subtractions, that sort of thing, it might not be a big gas savings versus Solidity, but it still can enable these other languages if you want to build in other type-safe languages like Rust. So it can be useful for writing safer contracts and things like that as well. Yes, going over, it supports alternative coding paradigms, helps onboard developers from Web 2, and we want to get access to the 20,000 Rust devs that are out there, and there's also hundreds of thousands of other developers in other languages we'd like to onboard. So these are kind of why we built Stylus on Arbitrum. All right, so to get started with it, your primary resource for working with Stylus will be docs.arbitrum.io. And in there on the sidebar, we have a section called Write Rust Smart Contracts, or Write Stylus Rust Smart Contracts. I forget what it says, but it'll be on the sidebar. You click into that, and if you go into the quick start, you can follow that to like get all the prereqs installed in your system. you'll need Rust installed. You'll need Docker installed in your local system. And Rust Up is the CLI tool. There's a couple of CLI tools that will come in handy. But just follow these instructions on there, and it's very easy and quick to get going. There's another section of the docs called Run a Local Dev Node, and that's going to explain how to get a virtual Arbitrum node set up on your local system. So for quick deployments and for the purposes while you're at this hackathon, you'll just want to work locally against your local Stylus dev node or Arbitrum dev node. So look for that section either under the Stylus section, or I think it's also somewhere else. But also, if you, for the purposes of the hackathon, if you want to submit on the price track, you'll want to deploy it to Arbitrum Sequoia. And here are 3 faucets you can use. These faucets are also listed on the docs at arbitrum.io. So if you need some testnet ETH, and also if you need more than what the faucets are giving you, just reach out to us or come to the booth, and we'll send you some testnet ETH. So just let us know. Okay, so again, Rust's primary advantages over many other languages, or over some other languages, is that it's a very strongly typed language. It's memory safe. It's got a lot of high-level language features, so it kind of feels more like a modern language like Java or C#, or it's got a lot of high-level features, but it still remains a systems-level language, so it runs close to the speed of C or C++. So it's very fast, it's very efficient. So Rust has been growing rapidly over the past few years for those reasons. It also has a very powerful compiler that will a lot of times just let you know specifically what line of code is incorrect. And so it's a very helpful compiler. It also has like some cool features like pattern matching. As I said, it's very fast. These are kind of how you work with variables in Rust. You can either define variables are actually immutable by default. So when you say let x equals 5, that's an immutable value. But if you say let mute x equals 5, that's a mutable value now, and you can now mutate that value. These are some of the data types that you have access to by default in Rust. These are unsigned integers. By default, Rust supports all the way up to unsigned integers of 128 bits. But for Stylus, we have a library that we bring in called Alloy. That's from the Foundry team. But we use it as part of our SDK to give support for 256-bit integers, since you need to maintain that Solidity compatibility. But this lowercase u, these are the native Rust types. So sometimes when you're working with SDK, you'll need to parse from native Rust to Solidity types. But I'll get into that later in the demo. But these are just the native Rust types that you kind of have access to. This is what booleans, characters, tuples look like. A tuple is just like kind of a set of values, and arrays. This is what a function looked like. It's very simple. F in main, you print line, call a function. So again, this is just working with functions, very simple. And for the most part, for the hackathon and whatnot, I would recommend just kind of sticking with basic functions, calling other functions, just to keep your code simple and straightforward. This arrow syntax, where you see the +1 function down there, that's how you return a value. So you just use that arrow syntax to indicate the return. This is a struct. So this is if you're setting up a data struct. You'll use structs quite frequently in Rust. This is just a rectangle with a width with a 32-bit unsigned integer for both width and height. It's very similar to objects in OOP languages like Java or whatever, but they are slightly different. Rust tends to eschew things like inheritance as a design principle, but so a lot of times with Rust adopts something called composition over inheritance. So a lot of times you'll just attach methods to structs, and you'll implement traits. But I don't know if I'll get into that too much in this talk, but Yeah, like just know that traits are kind of like interfaces in other languages, and you can implement traits for structs in order to create behavior for the rectangle, like a computing area or something like that. Yeah, this is just giving an example of declaring a rectangle. There's multiple ways to do this, but this is just one of the default ways to declare a rectangle and instantiate it. Yes, what I mentioned earlier with impling. So right here, what we're doing is we're creating an area method on this rectangle. So we've got the rectangle struct that we defined above, and then the impl rectangle. Impl, you can think maybe implement. Like it's just impl rectangle. This is how you by default attach methods to a struct. So you just impl for that struct, and then you just define your functions down below. And that and self is a reference. That's just a reference to the instance of the rectangle itself. So that's always the default first parameter, and it's a reference there that you reference for the first parameter on the method. So that's very straightforward. Self.width times self.height gives you the area, which returns a U32. Rust also has access to something called enums. Enums are very powerful in Rust. They're very simple to declare. You can also impl things for enums. Right here, and it also enums are very powerful for pattern matching in Rust. So what you see right here is an example of pattern matching, where we got a coin type, coin enum, and then we've got value and cents, and we're just matching on that value, and then we've got all the matching arms of that enum that could possibly be. And Rust forces you to always handle all the possible enumerations. So you always have to either explicitly declare each value, or you can provide a default arm on that match statement if you need to cover just the basic default use case, if you only want to define one for like penny, for example. Okay, so this is some control flow, kind of more advanced control flow type things you can do. You can say let config max equals sum 3u8. So what that statement is saying is that if that config max is going, if it has a value, like if this is Rust has this option type where it can either be none or something, and that sum keyword is just like it will, if this value has something in it and it's not, if it's not the none type, then it will match on that sum branch, and it will. What this is doing is matching on config max, which we already assigned it the value of sum 3u8. 3u8 is an 8-bit unsigned integer with the value of 3, and we're matching on that config max, and then given that it is something, we're going to parse that value out as max, and in that matching branch line right there where it says print line, that would print out the number 3. So yeah, this is just a little bit more advanced syntax, but takes a little bit getting used to, but it could be very elegant when you need to make use of this. But I highly recommend learning pattern matching as you get more advanced in Rust. As I said earlier, traits are kind of like similar to interfaces in OOP languages. So this is how you define behavior for structs or enums. And so right here, I've got this summary trait with a summarized method, and I'm just declaring the interface for that method. It doesn't take any parameters. It receives a reference to self, but it returns a string. So that's the summary trait. All right? And this is an example of that in use, where I've got a tweet struct with username, content, reply, and retweet. And I'm then implementing the summary trait for tweet. And on that method, so that I'm implementing that summary trait. And that gives, now that tweet struct has that behavior, the summary behavior. So I'm always, with an instance of tweet, I can now call tweet.summarize, and and get the username and content back printed to the console. That's essentially what this does right there. Macros are a powerful concept in Rust. What this does is allows program code to be generated at compile time. This is not something you'll learn if you're new to Rust. You won't probably be able to learn this this weekend, for example, but you will make use of macros, and you'll see them in practice. So when you see this exclamation point, like print line with an exclamation point on the end, that is a macro being invoked. And also, there's multiple types of macros. The exclamation point indicates that it's a function-like macro. And so print line there is calling the print line macro function. And then it's what that's going to do when your code compiles. It's going to almost like generate code in the background, and then it's going to like kind of remove that line and then stick that code right there before it compiles down into regular assembly or whatever. So so that's what you need to think of as when you see macros. Just note that in the background when you're compiling, your code's going to be sort of like swapped out with the code that gets generated by that macro. And same thing with the hashtag, with the brackets, derive, debug, or whatever. If you see that syntax, that's a macro, and that means that the block after that. So that's usually like almost like an attribute like macro, and those are usually attached to functions or attached to structs, and that's just gonna. A lot of times it's just to like, it'll save you time from writing a lot of boilerplate that you would otherwise have to write. So macros are really powerful, really useful. If you're new to them, just note that this is what's happening, but it does take a while to fully wrap your head around macros if you're totally new to them. We do make a lot of use of macros in our SDK, and I'll go over some of those in just a second. Okay, so we wanted to do simple design patterns with our Stylus Rust SDK. We made use of Alloy, which is a primitives library that is gives you access to swap between values, between Solidity compatible values and Rust compatible values. And I'll show you that in just a second. When you're working with Stylus, you'll want to use Cargo Stylus. Cargo is Rust's CLI tool, and if you just if you want to create, once you've installed that locally, you can just call Cargo Stylus new my first contract or whatever, and it will create a little basic counter contract locally. And I'll show you that in just a second. As you're working with your contract and as you're editing it, you'll want to call Cargo Stylus check every so often, just to make sure you're fitting within the blockchain constraints, because we do have some constraints on chain. Contracts need to be under 24 kilobytes, and we have to we do some compression, so it can be a little bigger than that. We do run some on-chain compression to try to get it under 24 kilobytes, and running Cargo Stylus check will just make sure that your code is still under the limits. If you need more than that, you'll have to break it up into multiple contracts. Once you're ready to deploy, you'll call Cargo Stylus deploy with an endpoint and a private key, and it will deploy to either your local chain or a remote chain. These are some of the primitive types. Like I was saying earlier, when you're working with Stylus, you'll use these alloy types. So you'll use this capital U8 and this capital U256. Remember, earlier it was lowercase u. That was the native Rust integers. These are library integers from our SDK, but they are built on Alloy. So these are Alloy types. And essentially right here, I'm declaring an 8-bit integer from the number 1. So that's just how you work with our Stylus SDK integers. So sometimes you'll need to parse from one to the other, and that's how you do it with that U8 : from 1 or whatever to parse from native Rust to Solidity types. This is how you do addresses in Rust. You'll use like Solidity style addresses. You'll use that address type, and you'll : from, pass in. Well, this is just like filling all 20 bytes with ones. So that's an example of how to do a quick one. But you could You could obviously fill out the whole range of the 20 bytes if you wanted. Right here is, again, local variables. These are the different types of variables that you'll work with. Local variables, which just use memory. State variables, which use state and store on chain. And then global variables, which are values available in the VM. So those are usually referenced from within the SDK itself. You'll just pull those in as library values, and then you can reference those. Remember earlier I was showing you that hashtag with the as a macro type. So that what you're seeing right here is Solidity storage macro, and what that means is we're declaring a struct type right here. This is us setting up our state for our smart contract for how our state's going to be laid out. And that Solidity storage macro is saying to Rust, this is gonna lay out everything in a Solidity compatible way. This is also going to be the entry point struct. There should be exactly one entry point struct in your smart contract, and that's kind of your top level struct. That's your root level struct, if you want to think of it that way. You can have other Solidity storage structs, but you just need one entry point struct, and so that's going to be the root. And so your storage is going to start with that initialized variable, the owner variable, and then the max supply variable. So you've got a Boolean there, an address, and then a U256. And those are the storage state on chain. All right. When you're actually, I need to update the slide. Sorry. This external macro is now called public, but I think both will still work. But we did deprecate externals just to kind of match more with Solidity. So use public when you're, and if you'll see it, if you just clone the default counter, it'll show public. So stick with that. But that public method, that public macro or that external macro, what we're doing there is we're implementing on counter, and we're setting up our public methods that expose our API, our Solidity API for methods that external users can call on your smart contract. All right, let's jump into the code. Those are price tracks, but let's jump into the code. I've only got a few minutes, so I want to hop over to that real quick. So real quick, I'm going to do cargo stylus. So this is this is assuming you have everything set up. I'm going to say cargo stylus new counter demo right here. And that should clone in, and I think I should have it over here. All right, so I'm going to click into lib.rs is the default main file that you'll be editing on your smart contracts. And just kind of walk you through this real quick. There's some comments up here. We'll skip past these comments. A lot of this is boilerplate code that you'll just leave in place. This is just so that you can export the ABI for your contract later. So kind of just leave that in place. These are our dependencies we're pulling in from the Stylus SDK. We're just pulling in unsigned 256-bit integers from the Alloy primitives library. And then this prelude star is just kind of bringing in a lot of different things that we can just reference, like this entry point macro and stuff like that. These commonly used things that we need access to. So that star just brings in those dependencies for us. What you see here is this sol storage macro. And this allows you to declare your types in a Solidity compatible way, right? So I think on the slide I used the Rust style way. There's two different ways to do it. But using this Solidity style, you'll actually use Solidity style syntax to declare your state, to lay out your state. So that's exactly, we're essentially within this writing out Solidity, like U256 Solidity. So that's a 256-bit number that is going to track the state of our counter. And again, we attach this entry point. So that is the root level struct, the root level storage struct for our smart contract. Okay, and then again, remember I said it was external before, but it's public now. So just stick with public, and we're implementing for that counter up here that we declared. And we've got a number of public methods available, including number, where we're able to get the number from the storage, the value of the storage. We're able to set the number to whatever we want. We can multiply it by a number, we can add a number, or we can just increment it by 1. All right, so the way that works in practice, so like, yeah, right here, we made these public, and that means it's going to get exported on the ABI. We also, for mutable functions, so this and mute syntax, and mute space self, that means this function is a mutable function. It mutates state, or it's able to mutate state. So when we're calling self.number.set new number, we are setting that number to that value in storage. So on chain, that will be stored on chain to whatever we pass in. Okay, getting real close to time, so I'm going to breeze through this real quick. But CDLS, CD counter demo. Okay, cool. And we got cargo, stylus, deploy. Okay, so I think locally I have like some environment variables set up. This no verify syntax is just when there is a contract verification that can run locally that can take a little bit of compute time. If you want to just deploy real quick, you can skip the verification step. That'll come later if you want to verify your contract on Etherscan or whatever. But then, yeah, I'm passing in the endpoint with a local RPC variable and the private key, which is provided to you by when you set up a local dev node. If you look on the docs, there's a private key that's given to you with local ETH that you can use for that. So you'll use that private key to deploy, and it'll deploy locally. It'll look like this, and once it gets deployed, should be quick. It's compiling. Deployed. Okay, came out 7 kilobytes. So we're going to copy that address there, and I'm using the library called Cast, which is from Foundry. So I'm going to set this to our new contract, and then. So Cast is a great tool if you're, if you're, for either if you're working with Solidity or whatever you're working with. So it's a great tool for interacting with on-chain contracts from the CLI. So, I meant to do call there. I did send. So real quick, I'm just going to call the counter. It should come out to 0. All right, and then when I go up here and I click, this time I'm going to do increment, and then I'm going to cast send increment. Okay, so that actually worked on chain, and then cast call. Now if we call the number again, it should say 1, right? So it came out to 1 there. So again, if I increment again, it should be now 2, right? So that's how that's just kind of how you build. This is very, I think this is very approachable if you kind of stick with the easy parts of Rust. Rust can be intimidating, some of the more advanced parts of Rust, but I think, if this is new to you and everything, you kind of start with the basic contract and then mutate, add functions that accomplish what you want, but yeah, I think it can be doable even if you're brand new to Rust in a weekend. So